So thanks, a big thank you to Augusta for hosting us. If you're turning on the Wi-Fi, which I assume you will need because people will want to follow along. Augusta guest is the network, and guest cloud9 is the password, capital G, capital C. If you've forgotten it, here's a tiny little piece of paper with the name on it. So we are the Google Developer Group Twin Cities. So this is a volunteer-led organization. We actually have a bunch of the organizers here tonight. We've got Lloyd, our fearless founder and leader. We also have Jeff in the back. And we have a couple other members who are not able to be tonight, Patrick Fuentes and Valerie Lockhart, who some of you may have seen at the DevFest event that we put on in February. We have a few upcoming events. So we've got our regular meetup is going to be the first Tuesday, so about a month from now. But we also want to call out that we have a special event. So Google Cloud is putting on their big yearly conference. They're calling it Google Cloud Platform Next, or GCP Next. And we're going to be co-hosting this with Augusto on March 23rd and 24th. We're just doing the keynotes, so it'll be at about 11 a.m. Central Time on both of those days, going to about 12:30. Paul, do you want to say anything?
Yeah, that's about right. We'll have food of some sort for lunch, and so hopefully people will stop by and watch the keynote. There's usually some pretty big announcements about the platform during the conference.
I hear it got faster and maybe cheaper.
There's bad news. We can count on that.
And then, for the ones who already know about this, but we're still running our study jam. I think we have 2 more sessions of that. Attendance has actually been huge. We have like 100 RCPs to every event. And people are, how many people have been to one of the study jams for beginning Android? Is it going well? Yeah, we're hearing really good things. So it's too late to join now, I think, but Patrick is the one leading that. He's doing a fantastic job. Just a little note about the kind of community that we're trying to create. So it's an inclusive community where developers, designers, and entrepreneurs of all skill levels, genders, religions, and backgrounds are welcome to learn, practice, and share Google technology, services, and platforms. That's a huge mouthful, but we're kind of stealing the bill and Ted, be excellent to each other. And then we really do want to encourage inclusiveness, so if you see or hear anything that doesn't match that kind of mentality, Lloyd Clevin, he's the enforcer of diversity and inclusiveness. He's here to help. So a little bit more about Google Developer. So founded about 4 or 5 years now, by the way. 6. 6, wow. It was originally the Google Technology Users Group. So this is the webpage, developers.google.com. Android, Chrome, Drive, Google Cloud, basically any API platform that Google is launching that people can build cool stuff on, that's what we're focused on, that's what we're talking about. Right now, so we took a little bit of a tumble. We used to be something like 2nd or 3rd or 4th. We're now tied for 7th place. So the attendance tonight, the surveys and all those things that we're doing, we're hoping to get back up, as well as some better record keeping on our side, I think, will help get us back up near the top. There's a program that Google also puts on called the Google Experts Program. So I'm an expert in web technologies. If you're interested in joining that program, I think they're always looking for kind of people that speak conferences, write blogs, contribute to open source projects, things like that. Let myself or one of the organizers know if you are looking to become part of that. GDGTC.com is the webpage where we host things, but really meetup is the best place to go in terms of if you're looking for information about the events that we're putting on. Which brings us to the meetup page. So meetup.com, GDGTC. You'll see the Go workshop on there. You'll see all of our other study jams, and very briefly you'll see the Google Cloud Platform Next events, the viewing parties that are going to be here. We already talked about the code of conduct. And then lastly, at the end of the day, after the session, we would love your feedback. We actually, about 3 or 4 months ago, they run a contest every month of, based on the surveys, who both an individual winner and a chapter winner, and I think we just won for the 2nd time as a chapter. We've also had the individual winner. I'm going to verify that, but I think we won again. So we are one of the best groups that have done the surveys. So thank you guys so much for that. If you're looking for where that is, tab over here. It's bit.ly, GDG Survey TC, and then we're also looking for people who volunteer to speak. We were actually just before we were doing some of our calendar planning. So we were trying to pack a lot of stuff. I think we counted like 26 events this year. So it's going to be pretty crazy. We're going to be doing a lot of Android, a lot of cloud, things like Vision API. So if you guys have something you're interested in talking about, let us know. This definitely is a community-led, community-run organization. So. And with that, I want to introduce.
Make sure that we thank our hosts.
Oh, I started there.
Oh, you started there, but and I don't know if there's any other. So Augusto has been one of our longest partners, I think, running and really made the success of GDTC possible. So huge thanks for food and the space to Augusto and Paul and their team. Anything to say about Augusto proper, more than just the event that's coming up, or anything else?
I think so. We're kind of planning out our year. Some big things just happened this week. We're going to be kind of planning for our hiring for this year. Most of our staff is going to be the first half of the year, so look for some announcements and job postings if you're interested at all in what's going on in the cloud platform. We're mostly Python and lots of Google Cloud Platform. We're also doing Chrome development for our product. So those things are interesting. Catch me sometime and chat.
Yeah, if you look at just by the numbers, I think they host more than half of our meetings, and that includes things like our extended events and whatnot. So huge thanks to Augusto as always. All right, with that, I'd like to welcome our speakers here to talk to us a little bit about Go and the adventure thereof. What was the Wi-Fi password? Anybody else need the Wi-Fi password? Good?
All right, so again, thanks to the Google developer group for having me here today. This is fantastic that I'm allowed to actually come here and present. And again, thanks to our host, Augusto. Thank you very much. This is awesome that they give us the space. So with that, I'm going to get into the actual presentation. So tonight, we're actually going to talk a little bit about what is Go, why does it exist, and we're actually going to do some hands-on programming. So I promise this will be painless. All right. So the first thing I like to do when I get these meetups or these workshops started is I like to get everybody actually on Slack. So who's familiar with Slack here? Read? Okay, that's fantastic. So there's an action role for Slack. It's very, very active, and this is going to be a place that you're going to go after tonight when you have questions about Go to actually ask. So why don't we get everybody real quick to get on the Slack there. So if you just follow the first link for the invite, that'll send you an email, and then we're actually going to use the training channel once we get there. So if you can do that real quick, I'm going to flip over to Slack. And
Can you bring that back?
Yeah, we can't type quite that fast.
Alright, we'll keep that there for a minute. Sorry about that. And then I'm also going to use this for the training channel tonight, so I'll be sharing links with you as we go to make it much easier to do your development tonight. This is also how I secretly inflate the Gopher Slack numbers. Just don't tell anybody. Yes?
Since all of us got here from meetup, if you copy that and paste that into the meetup as a note or comment for today's meetup, then everyone here will get a little alert on their phone, and they'll be able to click on that to get to that address in the hour later.
Automation, what a concept.
Okay.
Thanks.
Done and done.
Cool.
everybody doing? Pretty much there? You on track? Good. Alright, so while we're finishing that up, I'll just be sharing stuff in here. The first thing I share is actually the repo that I'm going to present from tonight. So it actually has all the code examples in it, has the actual slide presentations, all that kind of good stuff. So if for any reason you need to reference back to that, it's going to be at that GitHub repo. And let's get started. Alright, so I'm a big fan of community. Community is really important to me. I've been in the Go community for almost 4 years now. And so the first thing I try to do whenever I come to a city that I haven't presented at is I try to get everybody to join the actual Go meetup groups. And I have people do this for a couple of reasons. One, even if you don't intend on going, I want you to show that you have interest in the Go meetups. So this is really important. So just by you joining any of these Go meetup groups that are in your local area here, you're actually informing the organizer that you're out here, you exist, and you actually are somewhat interested in Go. So if you can take time to do that at some point, that would be really, really awesome. And then the other thing I do is I typically put together a document that I try to maintain for each city as well. I've done this for Denver, done it for Chicago, doing it for Minneapolis. And really all it is kind of a community document. And it has kind of the status quo of, you know, where do I find information on Go locally? Where do I find the online communities for Go? So you're going to see Slack, you got the forums, you got the Twitter, hashtags, the meetup groups. You've got training that's going to be happening. You've got other events that are this event right here, and jobs. So if any of your companies are hiring for Go, let me know, and I'll get their job listing on here and try to help promote that, try to help everybody get connected. So that's really all this document is. It's very simple. I keep it pretty well updated. This has serviced really well in different cities. That's amazing actually how much traffic these documents get. So just be aware that it's out there. And that's enough promotion for now. And we're actually going to start. Again, this is where the slide deck is, if you need as well, the repo. Alright, so first of all, anybody here use Go before tonight? Okay, sort of. Anybody using it at work? Nobody? Anybody know if anybody at work is using Go? Fantastic, okay, that's good. So, yeah, Go is relatively new, right? Go actually came out kind of in this time frame one. All these other languages came out, believe it or not. So, I mean, you had Erlang and Haskell and Scala, like this whole like language explosion happened. And Go happened to be like in there somewhere, right? So I think Go hasn't put on as fast as we'd like it to be because it kind of got caught with like, oh, just another language, right? But here's just a few companies that are actually using Go right now. I think you're going to recognize most of these companies are actually pretty big names. And there's actually an entire wiki on who's using Go. So take a look at that and you'd be surprised. I find more often than not, almost every major company at this point is actually using Go. They just don't make a lot of fanfare about it. It's not like when, hey, we're using Rails now, we're using this brand new JavaScript framework, everybody's all excited and they do these presentations. Go is kind of a boring language, but that's okay. Like as a developer, you're going to find that it's actually really cool that's a boring language, and we'll get into that a little bit later. But you'll be surprised, most major companies are using it. So why Go? Like why do we have this new language, right? This is why. He's a mascot. That's simple, right? No, actually. So Go is actually created to make software engineering easier, right? So who here has done C before? How about C++? How fun is that? Okay, yeah, okay. Now I'm not here to look at other languages, right? Like I want to be really clear. I have a lot of respect for all the other languages that are out there. They all do certain things really, really well. But one of the problems that a company like Google has, and this number is actually quite out of date, I found out at one of the last conferences I had, I think they have close to 45,000 software engineers at Google right now. So when they talk about software at scale, they aren't just talking about software at the server level. Like, oh, how many servers do we have, right? We got to scale this. They're actually talking about software at scale at a human level. And let's think about that for a second, right? So if I have 45,000 developers and they're changing teams and going to different projects, every time they change a team and go to a different project, they have to find out, well, what are the rules on this project? I understand I'm doing C or C++ or Java, but nobody does it the same, right? Like that's kind of the deal. Where does the semicolon go? Where does this bracket go? Am I going to get in trouble? Is this bike shedding, right? So we kind of have this whole area, like you have all this downtime just joining a new team and getting up to speed, right? And they said, this is not scalable. Compile times. Who's had a one-day compile time on a project they worked on before? Anybody? Yeah, I mean, it's big projects is not uncommon, right? And at Google, it was really not uncommon. I think they had one project took 48 or 24 hours to compile. It was absolutely insane. And this is a lot of downtime. Like everybody has to have their code checked in by Friday at noon or else, right? Because we're going to build. So this is what they talk about at scale, not just machine scale, but human scale. Anybody know who Andrew Durand is? It's actually one of the core Go developers. So if you do get into Go, you'll probably see his name around. And he basically said software should be simple. And he actually said software can be simple. And this is a really important concept in Go. And so what he means by simple, right? He means it's small. It means it's readable. This is really important, one of my favorite parts. It's consistent, it's orthogonal, predictable, robust, and useful by default. And I have to put a note down here because I always have to look up what orthogonal means. So I finally put a note in because I could never remember what that meant. So go at a glance, okay? It's a compiled, statically typed language. It's a very clean syntax. It's a simple type system. Concurrency is a primitive, okay? So Go is designed from the ground up with concurrency as an actual primitive, just like an integer, okay? This is a really important concept because all systems today are multi-core, right? And Go takes advantage of that literally from the ground up. Super important. It has a very, very rich standard library. It's open source. It has great tools. And when I mean it has great tools, it's probably what makes, it's my favorite thing about Go is the ecosystem. All the tooling that comes with it. Just fantastic. And testing and benchmarking are also built into it. The Go command. So this is one of the tools I talk about. Look at all the things you can do with this. You can build, clean, fix, funct, get, install. There's a ton of stuff here. Half the stuff I don't even use. But I'm telling you, if you come from other languages, the toolset here is fantastic. I'm not going to bore you with everything in here today. But if you do adopt Go, get to know this toolset. It's very important. It'll make your life very, very simple. So this is your basic Hello Go, right? So we all know we have to do the Hello World right away when we run a program. I don't know, am I running this locally? I'm not. I don't know if this will run. Okay, so what I want to show you here real quick is I actually just ran this program, right? And I should actually run it locally just to give you an idea. Okay. And the first time it just has to actually spin the web server up. Come on, let me go. That's taking me a really long time. Just talk about how fast Go is. Better. Okay, Carl, this is going to work locally for me. All right, let's go back. Oh, there it is. All right. That's totally not going to work. Okay, whatever. So if I run this again, I just want to show something. See how fast it is? This is really important concept here that I want to get across. When I actually click the run button, here's what's actually happening. This text from the screen is going to get grabbed by JavaScript. It's going to get submitted across the internet to the website I'm running from. It's going to compile that code to an actual static binary. It's going to build that code, it's going to run it, it's going to capture the output, send it back over the internet. JavaScript is then going to redisplay it down here, okay? That's a lot of steps. Now let me show you this again. See how fast it was? That was really, really fast. That was how fast it could actually compile. It took longer to send it across the internet than it did to compile, build a static binary, and capture the output. Okay, Go is fast. Go is really, really fast. I work on a pretty big project, and it takes just a few seconds to compile hundreds of thousands of lines of code. Hundreds of thousands of lines of code compiled in just a couple seconds. That is very common with Go. So that's really what I'm trying to illustrate here. And again, if at any point anybody has any questions, feel free to raise your hand. I'm very interactive in my presentations. All right, so I talked about concurrency before, right? So basically, Go routines are these really lightweight threads that are managed by the Go runtime. And so when we talk about Go routines in Go, it's not a thread. So you have so many system threads per CPU, right, in a multi-core system. Go actually schedules Go routines on those threads. So it's not uncommon to have hundreds of thousands of threads or of concurrent Go routines running at any given point in a Go program. That's actually pretty common. It's not unexpected to have millions of them running. So some of the programs that I work on, we have tens of thousands of Go routines running at any given point. And it works really well. So I have an amazing schedule over there. So this program is really simple. Basically all it does is we put the Go command line in front of any routine or any function. Basically just spins them all when they run. Now these are obviously just going to put some different times in there so it'll run backwards when they come back out. But this actually ran concurrently. And this is just kind of showing like Go having the actual the Go routines as a primitive makes it incredibly simple to actually run concurrent code. And we're actually going to do some concurrent code tonight as well. So get into that. Channels are actually the second concurrency primitive that's built into Go. And basically channels are used to communicate across Go routines. And we won't get into that tonight because that's a little more complicated. But just understand that they're there. So if you get into Go programming, basically Go routines and Go channels. Those are the two things that are just kind of like peanut butter and jelly when it comes to concurrent programming in Go. There's an incredibly powerful net HTTP library there in the standard package. This is what's really interesting about this. So who here does any type of web development? Okay, we've got a few people. You run a lot of hardened web servers, all that kind of good stuff, right? So the standard library in Go, the web server in there is the same server that Go uses on dl.google.com, right? That's download.google.com, okay? That is an incredibly hardened, scalable web service. That's out of the box, that's out of the system library. So if you're going to write a web service that you want to be scalable, like at Google scale, this one comes out of the box. They didn't modify it, they don't have some custom version of it, they use the one that's in the standard library. And as Go 1.6 that just got released, they also have, what is the new HP standard that just came out? 2, right? So you see all of it in our web development, right? But yeah, so it actually has HP 2 support as well, which is really cool. And they're just continuing to enhance it as well. So you get all those new capabilities. So this is basically, if you want to run a server, this is very quick to do. Let's see, it came up on localhost 8080, but of course it's going to be on their server, so I'll really get to it. But if I was running locally, I could actually run this server real quick and start it. And this is all the code it takes to actually bring up a web service. That's it. Out of the box using the standard library. Very small amount of code. Now obviously, if you were running more sophisticated API servers, you'd have a lot more layers and this and all that kind of stuff. But just out of the box to show you how quick it is to actually spin up an actual web service. It's very quick. How many people here are Rails or Ruby developers? None? One? Okay. So in Denver, where I started this presentation originally, we had a lot of Rails community there. And so I reached out to a lot of the Rails people online and said that we're doing Go all the time, and I kind of said, hey, like, what tips would you give people that are coming to Go, right? And some of the things I always try to tell people, which are great comments like from Dave Cheney, is don't try to compare Go to Java, C# or Python, right? And Go is really interesting. When new developers come onto our team that have never written Go before, I can very quickly identify which language they came from. Like, oh, like you used to have been doing Java for a while, right? Like everything's a pointer to you, okay. Or, you must have been doing, Ruby because you're trying to do everything in one line. And it's just interesting to see them come and do that. And Go is kind of like a programming language that it takes a while to get the idioms down. So it's a really simple language on the surface, but it doesn't do things the way other languages do. So, what I can try to tell you is, really try to leave like your object-oriented brains at home, right? And really embrace the interface. So, this is an object-oriented language, but it doesn't use inheritance. It uses composition. It's a completely different concept from an object-oriented programming language, but it's really elegant once you learn it. There's a lot of Go editors out there. So if you don't have a Go editor tonight, any one of these will work. I mean, any text editor. Go is a simple language, so you typically don't have to get too fancy when you're learning Go. All right, so installing Go is super easy. Who has Go installed so far tonight? That's pretty good. Okay. If you don't have Go installed, does everybody have a link to the presentation at this point? Everybody out there? It's pretty straightforward. So on a Mac, Homebrew is a great way to install Go. If not, just go to golang.org/dl. All the binaries are out there. It is incredibly simple to install Go. So go ahead, if you don't have Go installed, get started on that right now. And then I'll keep going, and hopefully by the time you're done installing it, we should be into the actual programming code a little bit. So the only thing that really sometimes is a pain in Go when you first get it is setting up your Go path. So that's really like the hardest part of installing Go. The binary is installed very simply. And so again, like on Mac or Linux, it's literally as simple as doing something like this. Just create a directory called Go that you're going to use, and then export Go path. Like, that's really it. So if anybody needs any help with this, let me know. And kind of when I get the code samples going, I'll walk around and help everybody get this going. But pretty straightforward. Anybody running Windows here today? Maybe a couple of people. So this is the way that you'll actually do it on Windows. My experience with Windows is regardless of what they tell you and what operating system you're on, after you set the actual system variable, you have to reboot. I've seldom had success with anybody saying that it works properly. So just be aware of that. So if your Go path doesn't get set right away in your terminal, you may just have to reboot your computer. All right. So while everybody's getting Go installed that doesn't have it set up yet, what I want everybody to do at this point is go ahead and open up your favorite text editor. It doesn't matter which one it is, any text editor you want. And we'll actually do our first hello world, okay? And what this is going to do is basically to tell us that we've got Go installed properly is really all it's going to do, okay? The first one done gets a free soda.
I did right before it came.
You get free soda! And if anybody has any problems, let me know, because that's typically a sign of the Go path not being set properly, which is something that's pretty easy to typically get working. Normally I have a TA when I do a group this large, but I don't know anybody in Minneapolis yet, so I wasn't able to finagle anybody in to be a TA. And also at any point if I'm going too fast, please stop me, I'll slow down. Anybody gotten it to work so far? People? Okay. Hands are going up. It's good. It's a good sign. Does anybody have any install problems? Anybody needs any help? Yes. So, are you following along on, do you have the presentation open by chance? Oh, sorry, we posted in the meetup again. No, so go to the home one there. I posted the actual.
Just use your arrow, go over to the right slide. Slide 27 or 28. Go to the next one, so that'll be the windows. There, right there. So.
Alright, so now who's got the program running? Show of hands. Okay, that's pretty good. Alright. If you didn't get it, don't worry. I'll come around and help you on one of the next examples, like we'll get you going. Definitely want to make sure everybody's getting up on this. Okay. So, alright, so now we're going to write some more Go code. So that was basically just making sure your Go path is set up and the basic stuff works, okay? So the first thing we're going to do is we're going to create a basic CLI program. Anybody here do a lot of DevOps type stuff? Okay, got a few. What's your favorite language to deploy across systems? Like Java, Ruby, Bash. See, nobody has a favorite language to deploy, right? I know why that is, because it sucks. Okay, it's no fun. So really, the neat thing about Go is everything's a single static binary. So when you build a Go program, the deployment story for Go is ship the binary. That's it. Ship it to Windows, ship it to Linux, ship it to Mac. I don't care, ship it to an ARM device. It's the binary. You're done. That's the deployment story. So if you're from DevOps, you're going to love Go because it's easy to deploy. So the first thing we're going to do is we're going to cover the flags package, which is pretty straightforward. So the first thing I need everybody to do is just create a file called CLI.go. So that's what we're going to name it. And this is what we're actually going to put in there. So now this is a great time that if you haven't been following the presentation, now's a really good time to do so unless you really like to type. And that's okay if you like to type. Personally, I like to cut and paste. And really all I'm going to do is I'm going to kind of explain real quick what we're doing. So if you're familiar with command line programs, you're probably familiar with passing in arguments, right? So pretty common concept. And in this case, all we're really doing is we're reporting the flag package, which is saying, I want to declare a string variable. I'm going to give it a pointer to my variable I declared, and it's going to be called CMD, right? And we're going to do something really simple, right? I'm just going to basically parse it in. When you call flag.parse and go, this is what tells it, hey, parse all the arguments now to anything that I've set up. This is a very simplistic version of the CLI program. Kind of gives you an idea though, and I'm really trying to illustrate how easy it is to create an actual static binary CLI. And then we do something very simple, right? Depending on what you put in, I basically just go ahead and I say, hey, base, if you said hello, I print hello. If you said bye, I print bye. Otherwise, I print the flag.usage, okay? And the flag.usage is really nice because it knows already, based on how I set variables up, what the usage should be, right? So I don't have to go and always maintain in my CLI program if I change information, either in the help or the descriptions or I add arguments. I don't have to update any usage in my program. Go actually does that for me, which is really, really nice. So let's take a look at that real quick. So if I've got that running, all I have to do to run is just basically go run CLI. So let me flip off to my terminal. I need to make this much bigger. Okay, so you can see, just so you can go run real quick, maybe I can figure it out over time. By issuing this command, it runs it. Now, you're seeing this crazy long usage of that program right there because basically I didn't compile the program, I'm just using go run to quickly run it. So it doesn't know, it compiles the actual binary into a template folder. That's all you're seeing there. But we'll get away from that in a minute when I actually show you how to compile. And what it does, it says, this is printing out the usage. Remember I said if I don't send in either hello or bye, that's going to print the usage? This is what it does for me automatically. It gives me this whole really nice string. So if I have a whole bunch of arguments, it's going to print out all the usages for me automatically. I don't have to manage any of that, so it's kind of nice. But now if I do this, actually tell it something, like that, press hello, just as I would expect, right? So very, very simple. Nothing super exciting here. It's boring on purpose. So that's what I just showed you, right? To run that. Did anybody get that to run? Okay, a few people. Did anybody try it? Okay. If it didn't work, let me know. We'll get back to it. But it's pretty straightforward. But the really cool thing here, and I already talked about the streambar package, is actually building it, right? So if I go ahead and I want to build this, that's all it is, right? And so now if I look, I have a basic binary right there, okay? It's a little bit bigger than C, because it does put kind of a lot in for really small packages, but as your program gets larger, it's actually pretty small binaries at the end of the day when you look at it relative to how many lines of code. So now, if I just run basic, that's my program. And now you see usage of basic, so instead of that crazy long variable string and all that kind of stuff, that's what it is. And if I pass in a command to it, that's it. So that's a CLI program. It's a static binary, and I can now give this to anyone in a Mac, okay? But what if I wanted to give it to somebody here on Windows for my computer? It's actually as simple as setting the environment variables. So on a Mac, I can do it at the terminal just by setting it inline. And now if I look, I actually have a Windows binary that I just compiled from my Mac that I can put on a thumb drive and hand it to a Windows user. That's the cross-compile story with Go. It doesn't get any easier than that. So if you're writing CLI tools for your company and they have to be cross-platform compatible, this is your friend. You want to write your CLI in Go. Believe me, you're going to make your life so much easier. In fact, if you look nowadays, most major companies that are doing anything cross-platform support, almost all of their CLI tools are all written in Go. Look at like Heroku, DigitalOcean. There's huge names out there. They're all written in Go. Anybody here use Heroku? No? Yeah? Ever use the command line tools? You're using Go. So just to give you an idea. All right. And there's some links here too. If you want to look at the environment variables, or the data chain, or a great article on how to compile, how to cross-compile as well. So there's just more resources there. So take a chance to take a look at that. But let's get into like the cool stuff, right? So let's get into concurrency, okay? Now, Rob Pike, who's one of the creators of the Go language, he did this really, really good video on concurrency is not parallelism, okay? And I can't even begin to explain it as elegantly as he can in this video. So if you really want to see this video and really understand concurrency is not parallelism, go ahead and watch this video. It's not very long. I promise you, you'll like have this epiphany moment, like, oh my goodness, like, I get it, it's brilliant. Great, great video. It's literally the first video I ever watched with Go, and that's how I fell in love with Go. So I definitely encourage watching that. So I always like to show people, if we do a lot of command line programming, most people like, we have to do batches of things all the time. As programmers, we're always dealing with, I got this batch of things I have to do, right? And I'd like to do them concurrently, but that's a lot of work. So I'm just going to do them sequentially, and I know it's going to take an hour. I'm going to go to lunch, I don't care. And I'm just going to live with it, right? And with Go, you don't have to suffer with that kind of pain because the primitives are built in. So in this case, I'm going to show, like, what if I had to retrieve a bunch of websites, right? For no good reason whatsoever. Maybe I just want to retrieve 100 websites and measure the response times they take. So to keep things simple, this is the first program, right? So we just run over the flag package, and And at this point, I'm just literally going to create a very simple program that just parses all the args and echoes them back home, okay? And all this really does is something this simple. Let me show you. So you can see all it does is basically whatever I type in for arguments, it's just going to echo back out. Okay? That's important because of what I'm going to do next. I'm just showing an example of how I'm going to parse a bunch of input, because the next thing I'm going to do is I'm going to parse a list of websites from that. So imagine, if you will, that I was actually passing a list of websites like this, right? Give a little more context this time. Alright, right? So that sheds a little more light on what I'm headed for, right? So basically I'm just saying, I'm going to pass you a bunch of websites, and you're going to parse them as arguments. And that's going to be my input for this program that I'm working on. So again, very simple program here. Literally don't define any arguments at all. I'm just going to parse whatever comes in from standard in at this point. So now let's actually retrieve this, right? So now we can start building the program. So we talk about the imports all the time. So we're using the flag package, the func package, the HTTP package, and the time package. These are all packages in Go's standard library. I mentioned earlier, but you might have missed it because I was talking about all the cool things about Go. This thing is a very rich standard library. And here's what I learned about doing Go in 4 years. If at any point it feels like you've dropped really low level and you're running like some HTTP protocol thing because you can't get at something you want to get at, it's because you missed something in the standard library. It's in there. Like, all this stuff is really well written, and there's amazing support for all of these things you want to do. You just probably missed it, and now you're running all this low-level stuff, and then you're going to be mad because 2 days later you're going to rip it all out and replace it with one line from the standard library. So I've done that, I can't tell you how many times. So just be aware that if it feels too hard, it's probably because you missed some really easy command in the standard library. So again, here all we're doing in the main function now is we're just going to parse everything like we did before, but this time I'm going to set a local variable to the flags.args. All this does is gives me a slice, and a slice is what you would probably refer to as an array in other languages, but there's slices in Go, and we won't get into the details, but call them slices for a reason. And now I have a slice of sites at this point, right? I'm going to capture the current time, so I want to keep a time on, like, all right, what's the start? Like, when did I start this process? And then I have another function defined, or another method defined later on, which is called process sites. It's going to take that array, it's going to go through them, we're going to go through them, we'll show you that method in a minute. And then I'm going to print out at the very end, hey, it took this long to happen, right? Very straightforward. So not a lot of like super interesting code here yet. And then here's my process sites method, right? And all it does is it ranges through the actual sites that I sent in, and it sets begin time, it actually retrieves the site, and if I don't get an error, if I get an error, I'm going to say, hey, I'm an error. But I'm just going to continue, because I'm not going to break, that's okay. If I get an error with one site, I don't care. And then I'm going to print out basically all it took, what status code did I get, and I'm going to move on. Very straightforward, right? So nothing crazy here. Pretty straightforward batch program so far. And let's go ahead and run it real quick. So you saw basically these started running, right? So let's go ahead and run it again so you can see it. And you're basically seeing at this point that, you know, 123 milliseconds, 461, 421. That's interesting. Normally Yahoo was the slowest one. I'm surprised. Microsoft slower this time. But as you can see, the total time to process everything was almost an entire second, right? So while that's not bad, imagine you had thousands and thousands of sites that you had to process, right? Some of this becomes a very long process, right? It takes a long time. So we basically want to make this concurrent. We want to find a way very easily, how do we make this much better at what it's doing without adding a lot of code? And in Go, that's actually pretty easy. So all we're going to do is make a few changes. I think we're only going to add like 3 or 4 lines of code, this entire program, to make this concurrent. So you're going to see we're going to use a few more packages this time. We're going to use the sync package, which is new. And the sync package is something very common to Go that we use to basically manage concurrent programs. So at this point, this was just a little bit of code I added later on because there was a bug where if they weren't always separated, they had to separate the space. We don't need to worry about that for now. But it was just a bug I had. So So now what we do is, so right here, we actually define, where is it? We define a wait group this time, okay? And a wait group is a really simple concept in Go concurrent programming. All it is basically a concurrent safe counter. And what it means is that you can increment it and decrement it. But you can do it, it's basically concurrent safe, so you won't have a race condition. So who's familiar with race conditions in code? How fun are those to track down at 3 in the morning? Yeah, not fun at all, right? So Go tries really hard to make it so you don't have to track down race conditions. They have amazing tooling. They have a race detector that if it spots a race condition in your code, it's guaranteed to be a race. You can look at it all day long, and you can tell it's wrong, but I can assure you, it does not report a false positive. The flip side is it doesn't guarantee to find every race condition, but if it does find one, rest assured, you have a race condition. And it does a great job. We won't get into that today, but just know that's part of the tooling. So basically all we do is we create this wait group, and then we just call waitgroup.add, right? And we give it the length of the sites. And what this means, it means that if I passed in 3 sites, it's going to basically increment this counter internally in the wait group to 3. That's all it does. Because then I'm going to call waitgroup.wait here, and I'll show you where I actually decrement it. Here it just says, okay, until my wait group gets back down to 0, meaning everybody's done doing their thing, that's what signals me to just hang out here. Like, I will block at this point in my program until my wait group decrements to 0. That's all it does. So it's very simple incrementer decrementer, right? But it's concurrency. So it's really important. So most people are like, I don't like some variable, increment and decrement. Well, you'll pretty much your first time create a race condition. I can almost guarantee it. So this is concurrent safe right away, which is really nice. So now the actual process sites takes that wait group, right? It takes it as a pointer so it can operate on it. And all I do now inside of here is I create, this is called an anonymous function, but all I do at this point is basically I go ahead and defer this wait group that's done right here, okay? And what that does, defer is a really super cool thing in Go. Who deals with opening files all the time in like different types of programs? Who opens files, okay? What's the #1 thing you have to do with a file when you're done with it? You have to close it, right? And in most programs, you have to close it somewhere way, way down the code, right? And what happens if up above that code you have an error and you just exit it, right? You never close that file handle. Now that file handle is leaked, now it's out there, and you've got this file handle that's locked, and then you get a call 3 in the morning and say, hey, I can't access my database anymore. Like, oh yeah, I must have had an error here, I didn't release the file handle, right? Defer is super cool, because basically you do a file.open and immediately defer file.close. And what that defer does, as soon as it detects an exit of the function scope, or the scope in which that defer was defined, it will run that piece of code. So it doesn't matter if you have 10 checks at some point to say, oh, if this error happens, return, if this error happens, return. At any one of those, as soon as it exits scope, that defer gets fired. So it's a really nice housekeeping technique. So defer is really, really cool. There is a little bit of penalty as far as performance, but most people never see it, unless like you're really, really tight loops. But just know it's not a for free, but in most cases, it'll never be your bottleneck. So all we do is we do a defer.waitgroup.done. And that waitgroup.done is a single decrement, right? So basically this program, if I did a waitgroup.add of 3, I have to call waitgroup.done 3 times somewhere in my program, or it will deadlock. It will never exit. And Go will actually detect all the threads are sleeping, and it will panic and go, hey, I don't know what you did, but I'm not going anywhere. I'm deadlocked. And it'll actually tell you the deadlock, which is really cool. And down here, this is really super important. See how I created this anonymous function up here? Even though I have access to these variables in that scope, if I don't pass them in right here, it will actually not see the proper version of it, because when it gets put on the stack, it won't see that. Because this actually gets put on the stack immediately with whatever was in memory at the time. So if I don't pass them in, it'll almost always be like the very last one. So just remember when you do your concurrent programming, you're doing anonymous functions, if you ever see like, why is it that I had loop through 3 items and it ran the last one all 3 times? It's really weird. Just remember I said that and you'll remember like, oh, I've got to pass this back in. So long story short, keep that in your mind. Okay, so now that we've done that, all this goodness here with this program, all I have to do is go back here and run my new version of code. This is now concurrent. And we will see that the longest time was Yahoo. We'll see, it did take longer. At almost a little over a second. And the actual time of the entire process took almost exactly what it took Yahoo to complete at that point, right? Because now everything ran concurrently. So now what will happen is when I have 1,000 websites, it'll only take as long as the longest website in the process. right? So if you're doing batch programming now, the longest thing it's going to take, the longest file you're going to process, that's how long your entire batch process is going to take. Granted, you don't run on memory and all that kind of good stuff, like if you ram up like 20,000 files of memory, like you don't worry about those things, right? But in general, this is kind of like a for-free type of concurrent programming. This is really, really useful for batch programming. Before I move on to the next piece, any questions on concurrent programming? Yes?
What is it in there that launches multiple threads?
It is literally this right here. So we define this anonymous method right here, this anonymous function. By putting the keyword go in front of it, I apologize, I should have been clear about that. Just by putting the keyword go in front of it, it signals the program at that point to take this function right here and put it on the scheduler. So basically what happens is we've got this for loop right here. When it gets to this, it takes this entire chunk of code and says, throw it on the stack. And then loops and says, throw it on the stack. They're not running yet, they're not even scheduled. But it will literally put up 10, 20,000 concurrent little routines on the stack, just like that. And then the scheduler starts scheduling them. Now, when you're dealing with programming nowadays, what's the number one thing you're waiting on in terms of programming time? Is it CPU cycles? No. Is it memory access? No. Is it I/O access? Yes, right? Most programs today are I/O bound, right? I/O bound to the disk, I/O bound to the network, and the scheduler is really, really smart. What it does is, like, if it sees a file not open and it's in a go routine, it puts it on the stack, and as soon as it sees it's waiting for I/O, it puts that routine to sleep and gets the next routine scheduled right away. And then it'll come back and check at some point, well, hey, like, did you get your information? It'll bring that thread back, that concurrent, back alive, and it says, okay, that routine's back alive now, it's got everything it needs from I/O, and it keeps going. So the scheduler is really, really smart. And what it does, it allows you to do concurrent programming. So if you're I/O bound, Go does a really good job of scheduling around that. So it's really, really clever how their scheduler works. There's like a lot of magic science behind it that I don't even understand. But that's why it does concurrent programming so well. So just know that if you're writing I/O bound programs, Go can do some amazing things concurrently for you to help. Any other questions?
Can I do more than one defer?
Yes. And they will, it's kind of like a FIFO, right? So as they stack up, they'll come back in the other order. I don't know if that's a guarantee though. I've run a lot of tests and I can never remember, I have to look it up. I think it's a guarantee, but I can't remember for sure.
Okay.
But yeah, you can do a lot of defers. You can also, there's another thing called a init, which is kind of like a magic method that you can do in any package, and it will run those inits right away when the package is loaded, which are nice for different reasons, but those aren't guaranteed to run in memory. So that's something that's kind of a gotcha.
Golang says it's guaranteed to be LIFO.
It is? Okay, that's what I thought. So I always have to look that up. I don't usually have more than one defer, because what I'll do typically is I like to, if I have more than one thing I have to defer, it's usually as part of an actual function at that point, and I'll just create an anonymous closure real quick and do a defer of a func and do what I need to do in there, and that's usually nice for debugging purposes. But it's very common, like if you open multiple files, to have multiple defers at that point. So totally acceptable.
You have that function defined inside of that loop. Is that just for simplicity?
Just for simplicity, right? So if I was a good programmer, so typically the rule is when I'm doing pull request reviews, right? When I see anonymous functions like this, it's usually like, okay, it's a code smell. Like what happened there, right? Typically it's like, oh, I was trying to get my proof of concept working. This was an easy way to do it, and then I never came back and refactored. So yeah, this is not a great practice by any means. I mean, there's definitely times it's acceptable, but in general, I don't like to see anonymous functions. Not everybody on my team agrees with me. Any other questions? Yes?
You mentioned that async is, or should say, concurrency is a primitive, but it looks more like a language feature, like Go is a keyword, right? In the language?
Yeah, Go is a keyword, but it's a primitive in a way that basically yeah, I should have Go course to explain that. They do a better job. It's built into the language. It is considered a primitive. And the reason I say that is because channels, which we're not getting into, is literally a primitive, meaning that you can send an integer down a channel, and you can send a channel down a channel. Like, it's a crazy concept. But those are 4 real primitives at that. But yeah, I mean, it definitely, it might be questionable or not. This is Go is a primitive itself. But
what we've seen so far has a primitive. So channels are kind of.
Channels are guaranteed to prove my point. Yeah, if you look at those, you're like, oh, like, that's just like an int. Okay. Any other questions? Is anybody excited by this? Are we going to give this a try at work now? No? Some crazy guy you're talking to? Yeah, okay. All right. So that's concurrency. And I actually have a link in here if you ever want to actually run. I've got like a static text file here of 100 sites. It's amazing how fast it actually runs. There's like one site that takes like 15 seconds. Everything else is done like way before that. It gives you an idea. So that's your first concurrent program, right? So anybody ever written concurrent programs like in Java or C, that kind of stuff? Okay, how was that easy? No, not at all, right? This is a little bit easier, right? And what's really important about this, even when you get into channels, you'll find that your programs in Go are really, really readable. Okay? Most people can come into that code, even a concurrent program, and go like, oh, I see exactly what that's going to do. I'm not confused by these crazy abstractions that some of the other languages make you go through to get concurrency working. And that's because this programming language is designed with concurrency as a first-class citizen. That's one of the big differences, right? That's why it's so easy to read. It's like, listen, concurrent program is hard, but it shouldn't be hard, right? Let's make it easy. And so I've been amazed at some of the concurrent stuff I've written in Go, that when I come back to it, I can show it to the developer and they're not confused at all what it does. It's very, very clear. So readability is super important. All right, so now we're actually going to build a web server, right? We're going to build a web server as strong and durable as dl.google.com, all right? So we're basically going to do a couple of things. We're going to spin up a basic web server. We're going to create some basic routing for it. We're going to do an actual template to output actual real text. Again, how many web developers in here? There's a few, right? Okay. If you've done Rails or anything like this will feel a little painful at first. And the reason it will is Go is kind of a bare metal style programming language, right? Like you're pretty low level right away. But it's kind of that boilerplate. Once you build your boilerplate, everything else is really easy. And if you've ever worked with frameworks before, like if you work with Rails and things like that, I'm not dissing on them at all, but you get into a situation a lot of times with frameworks where you've painted yourself into a corner and you need this access to this one thing and you really can't get it. You have to do these incredibly crazy things in your code to get access to that one thing that the framework didn't get access to, right? And it's really painful, and when somebody else comes on your team, they look at the code, they do a git blame, and go, who wrote this crazy piece of code, right? It's because you had to. It's the framework got in your way. And Go builds up from the ground up, so if something got in your way, it was you, right? You were the one that got in your way, not the framework. That's a really important distinction. And when I wrote Go for almost a year and a half doing web services, it was very refreshing because there was no framework in my way ever. I always had access to what I needed because it's a lower level. And at first it was kind of daunting, I won't kid you. Like at first I was like, well, am I qualified to be at this level? And quite frankly, if you know anything about HTTP, it's pretty straightforward when you get down to it. So, this is the very first part of the program we're going to write. So all this is right here, so just create a webserver.go file. I'm going to add these contents. And all it does is we're basically going to create a handle func. And so basically, a handle func is a type. So a func in Go is a primitive just like an int. And so you can actually find like these really crazy things like handle funcs in other languages, and it understands that. And the handle func basically is going to take a function with this signature, response writer request, and then we're just going to do something as simple as write out to this. And so if you look at fprintf, it writes out to a writer. We're going to write out hello world from %q, which is the path that we're coming in with. And we're going to log when we start up. And then we're just going to call HTTP listen and serve on port 8080. Okay. So I'm not going to go into all the thick details of like all these different system calls and things like that. But this is all it actually takes to actually spin up an actual web server. So let me go and do that real quick. Alright, so you can see that I spun the web server up, and when I do a request from it, I get that response, and now I can actually use something like this. And you see at this point, this web server is going to literally respond to any path I give it, right? So that's not a very well-behaved web service, right? It's kind of like, it's open. There's basically no routing in play at this point. So I wouldn't recommend that you build a web server that does this, because I don't know that you're going to get a lot of great satisfaction of it. But it's a great proof of concept to show like how quickly we can bring this up. So the thing that we really need next is we really need some routing, right? And there's some great routing packages out there. The one that most people start with is this one right here. It's the github.com Gorilla Mux. Now this is the first time you're seeing an import from a non-system package, right? It's the first time you're seeing this. So if you want to import code from somebody else's library, it's as simple as literally saying, give it the address to GitHub, and it will import their package to your code. I'm going to show you actually how it brings that code down in a minute, but that's really all it takes to do that. Does anybody spot a flaw with this type of importing? Does anybody see it?
The package goes away, you don't have a copy.
There's that. You typically have a local copy, because it'll bring it down once, but if somebody else goes to get that program, they can't run it, right? Like that package is gone, okay? So vendoring, right? That's what we're talking about here. We're not just talking about vendoring, we're actually talking about version management vendoring, right? What happens if he changes his API one day? That means that when I run the code today, and you run the code 10 days from now, it's actually not the same binary anymore, right? Like if he actually updates his code, maybe the API stays the same, but he could have introduced a bug. Because it's not, there's no version attached to this actual import, it's not the same binary anymore, right? So I'm not going to get heavily into that, just be aware that's an issue. There are tools out there right now that are starting to solve that problem, right? So if you ever dealt with like Ruby, you've got your gem package. If you get Node, you've got your, I forget what they call it, like 17 different ways you manage packages in there nowadays. Pick whichever one works for you. But anyway, so Go has that problem. They are solving it today. Just know that. In general, it's not a big problem, but it's something to be aware of. So we're going to use that package. And all we're going to do now at this point, we're going to say mux. So interesting, when you import packages, typically the last thing that you import is the namespace that you're going to use, right? So in this case, it's mux. That creates a mux namespace in my actual program at this point. I just call a new router. I don't even remember why I call strict slash anymore. It's been so long since I've done this. Apparently I have to do it for some reason. And then I tell it I want you to handle this func right here. And basically I want to say on the index, handle a index method that I'm going to give you. And I define this func down here as the index, right? So I'm just giving it, again, a function is a primitive, right? I can actually hand this function to this function, right? That's pretty common. I think people have done that in most part of our language. Not shocking, but again, it's primitive. And so the only difference right here now is I basically have a router in place. So let me see what happens now if I run this program. So once again, running it, no problem, I get that, fine. But now if I go to, we're already doing presentation mode, I noticed. Let's do this. Alright, so now if I do this, now I get an actual 4 whole page not phone, right? This is much better, because now the router is in place. And the router is working, and we told the router, hey, only respond to this one URL at this point, right? That's all we've told it. And so now at this point, if you ask for anything else, the router says, I don't have a route for you, right? You've asked for something I don't have, it's going to give you the basic 404. So you start to see how we start to get the building blocks of a router in here pretty quickly. So if we take this one step further.
I have a question for you.
Yes.
Do you ever have to worry about naming conflicts on those packages? So what happens if somebody else has a really cool package that says mux?
Yes.
Is there a way to say import this as that?
Yes. So what you can do is you can say something like that. So if you just put something ahead of it like that, you basically can say like, now I want you to reference that as this. And it does happen. Like, so you see how there's an HTTP package in the system library? You'd be shocked at how many people create a package called HTTP, right? And they're like, okay, well, there's already an HTTP package in the system library. Like, apparently, I didn't think that through when you named your package, but I can still use it because then I can just do something simple like HTTP dumb to signify that something dumb happened. But yeah, so you can do that. So definitely a good question. I don't end up doing that too often, actually, which is kind of nice. So I can't think of the last time I had to do that, but it does happen. And I typically label it as unfortunate when you have to do that, because it's certainly not good. All right, so did anybody try to run this so far locally? Who had a problem? That's right. What did it tell you?
Said it couldn't go get the package.
Right, it doesn't have it locally, right?
Yeah.
So, because we have that run this command. So go get is one of the system tools, and we tell it to run this. And what that does is there's a source directory in your Go path. If you look in there, it's going to basically bring in this package. It's going to create the source directory, and then it's going to create github.com/gorilla/mux, and literally bring that repo down. It's the equivalent of a git clone. And it's just managing it for you. And so this go get is a really simple way of like saying, I don't have to create my own directories, I don't have to do a git clone, it's just going to do that for you. Go get will work with Bazaar, Mercurial, Subversion, all these other version management tools. So it's not just Git. You typically see Git because they kind of won the war at this point, but that's why you see that. So now if you run this command, that should bring it up. Yes?
Is there some way to just make that go get everything in imports instead
yes.
of
Go get // or // I believe. And there's actually a better command like let's go get // -u -t something else. And basically it says get everything that I'm going to depend on in my package, not just for my package, but also for my test. Because sometimes your test can do imports that your package doesn't, and then you go to run your test and it goes, I don't have this package that you're asking for. So there's a magic command that I've kind of got by memory that you just run this whole thing and it does it right. The -u says, even if I have it locally, but there's a newer version, get the newer version. Which that's kind of like a heavy hammer, right? That can get you into trouble sometimes. That could be like, oh, I broke my API, I didn't realize it. So use that with caution. Again, that's why some of these version management tools are really coming along out there that are helping them. So now we got it to work after they did the go get. Nobody? Everybody gave up at this point? Okay. That's okay. I know this is going on. Okay, so we're basically almost done at this point. So this was just illustrating again that it still works on the strict slash for the index, but if I go to foo, it doesn't work, right? Now we're getting into templates a little bit. Here's what I'm going to tell you about Go templates. 1.6 made templates a lot easier. But if you've done any type of web development, Go templates aren't that fun. And I wouldn't recommend building a really big web service relying on Go templates. I don't think you'll be very happy with that. I think that the template problem has been solved really well by front-end JavaScript frameworks at this point. Certainly Rails had it solved from the server side as well as that was ever going to get solved. So typically I tell people if you're running a web service, write an API JSON RESTful service, right? Like do that. Don't write an entire website that uses Go templates. I think you'll hunt me down at some point and say, why did you tell me to do this? It's horrible. And it's not that it's horrible, it's just not as pleasant as other languages. So just understand that this is more just showing you that it can be done, not that I would recommend that you do it. So again, we've got our basic imports. At this point, we went ahead and defined our handlers. So again, this code looks the same. The only difference at this point now is that basically in our index it's a little more complicated. So this right here, we have a page data, I'll show it later, but basically we have a page data type that we define, and all it does is have a title and a body. And we're saying set this local variable called PD equal to a page data with a title with a value of index page and a field body with a value of this is the body of the page. That's all it does. We then render the template with a render method I wrote, and then if we don't get an error, I basically write out, if I get an error, I write out a bad request header, and then I write the actual error out. Otherwise, I just write out the actual template that I got back, which is a byte. And you have to write bytes. This is actually a string. It's a way of converting bytes to strings. I won't get into that too much. So some of this looks kind of foreign. Long story short, this is your page data. This is my actual template. And how you reference the variables in there is basically you get these super cool angle brackets, and then you put dot title in there. Anybody ever worked with, we worked with Angular before, right? So yeah, my first Go project that I did with a web service and using templates, I was using Angular as well. Guess what happens when you see this, right? Suddenly it thinks that the Angular code is Go template code. And then you end up doing things like, oh, well, okay, well, I guess what I really meant to say is I meant to say this, right? Yeah, and very quickly I was very angry at the whole world. So that didn't work out well for me. And I found it interesting, right? Because you had two technologies from Google at this point, Angular and Go templates, and they don't play nice at all. So if you use Angular and Go templates, you're really, really not going to like yourself. So then this is this really cool little method that basically takes the page data struct that we created and parses it with the system library into all this magic. It parses the template. There's a lot of code in here. It does a lot of stuff. None of it's interesting. Suffice it to say, it takes all of this work that I just showed you to basically get this. All of that work to get this, okay? So I'm hoping I made my point clear that it's not really conducive to a great work environment there if you're going to do templates. Again, they do some amazing things. I use templates a lot for scripting. I use templates to generate code. I use templates to generate scripts. All kinds of stuff like that, and they work really great. I do not use templates for websites in Go. I absolutely do not. So, showing that it can be done. I'm sure the people that just put all this work into the Go templates are watching this video soon. At some point, I'm going to get a call. But I don't use templates for that. So,
I have a quick question.
Yes.
In line 3, template, error, does it mean that it's a tuple that comes back out of the parse?
Yes.
Okay.
So, it's very easy to find multiple return values in Go, and you'll see most methods that do anything that can error out will return the value followed by an error. So it's a really common thing. It's also really common, I don't know if you've noticed, see how I've got this if error does not equal nil, do something, and then if error does not equal nil, do something. This is another shortcut for that. You have this in Go all the time. In other languages, they have a try, catch, begin, rescue, all this kind of stuff, right? Which tries to figure out at any given point anything possibly could have went wrong in the entire stack, right? And so that's one methodology. And Go pretty much took the approach and said, listen, if you know an error can happen, deal with it right then and there. And so I think a lot of people have an allergic reaction to Go right away with the error handling. Like, man, I can keep running this, I keep running this. Fundamentally, it makes your code really clear. And also, I can't remember the last time I had an error due to a nil exception or null exception or something crazy like that, because I'm always checking my errors all the time. And I'm checking them at the point that it matters. And things can't cascade out of my control because I didn't do a file and open and then not check the error, and somewhere later there's a catch up hey, your file is open, but you already tried to write to it. Right? All these type of things. I've also found that it's really nice because when I error out, I can put a really intelligent error message at that point, right? Exactly what went wrong. I caught it, I know something went wrong, and I can tell you very intelligent, really intelligent end user message hey, this is what went wrong exactly here, and I know why. So typically, if you're an end user with Go programming and they've done it right, it's typically really easy to see what you did wrong with their program. So, some people absolutely hate this. If you talk to Go developers that have been doing this for a year, this is something they don't even think about. It's really a non-issue with them at that point. So that's the template stuff, right? All right. So any questions with the whole launching web server, doing a web template, all that kind of good stuff? Yes?
Just one thing, I don't know what I'm doing here, so I shouldn't say anything at all.
That's okay.
Just to contradict what you last said, the only reason I learned about Go in any level at all was a project called Hugo, which is based on using the template engine you're saying doesn't work to build static websites. Yep. And it's freaking fantastic.
Yeah, I know Steve. He's a great guy, and that project really took off.
Yeah.
But yeah, that is a fantastic project, and it's fast, isn't it?
It's insanely fast.
Yeah. Yeah. So again, the power of Go at work there, and that's actually using templates. Yeah. So he found a great use for them. But again, he's generating things from templates. He's not using it to typically do what a normal website does. Yeah. Anybody else? Sufficiently bored you at this point? All right. So we're getting to the end. So keep in mind, I actually gave this presentation last time in under 60 minutes because that's all I had when I gave it. So that was really brutal. So if you want to learn more about Go, there's actually a tour out there called tour.golang.org. I say it's so-so. The reason I say it's so-so is I've been doing Go for 4 years, and when I take that tour, I still get confused as hell. I'm still like, I don't know what they're asking me to do here. I don't know why they're asking me to do this. So I don't know what they were really trying to get across there, but I get lost every single time I do it. So what I typically recommend to people is if you're an existing developer, there's this really, really good document called Effective Go. It's written by the core team. And it kind of tells you everything you need to know as a programmer about Go. Like if you're used to arrays and slices, here's why. If you want to understand pass by value or pass by reference, it explains that. It does a really great job. And what I tell people is, if you start doing Go development for any amount of time, read effective Go, and then do some Go programming, and then read effective Go again, and then do some programming, and then read effective Go again. Kind of see where I'm going here, right? Read effective Go at least a dozen times. I'm not exaggerating. Because there is so much information there. It's laid out really well, but you only pick up so much every time because you just don't have a grasp of the language yet. But if you read this, 6 to 12 times, I can assure you it's very valuable. It will really, really help you with your Go development. So, how do you get help? So this is super, super cool, okay? There is a sandbox out here that is basically a playground for Go, and it runs Go programs, right? And I can do this, and run it, and then I can say, so what's really cool about this, right? It's one thing to go ahead and just do some proof of concept things. What this is really, really useful for. Who's used Stack Overflow before? Okay, quite a few of us, right? Who has found the answer to a really hard problem you have with code, copied the example, and so excited, you go to your code, you paste it in, it doesn't pop. And you're like, son of a, you're like, this gets so mad, right? You don't have that problem in Go, because what you do in Go is you go out to Stack Overflow, you say, I've got this problem, I'm trying to do this, and then you link them to the Go example you wrote. Creates a unique URL. And you paste that in there. And then the person who's going to help you on Stack Overflow says, okay, they click on the link, they come out, and they say, oh, I see what you did. You really wanted this. And he shares it and sends it back to you. And you have a working code sample, guaranteed to compile. That's an oversimplistic view, right? And my point is, this is really, really helpful. We use this in the Go community all of the time to share our ideas and bug fixes and help people understand, like, what did they do wrong in the program, and here's how you do it right. And it's going to compile and run. And you can share these back and forth so you both agree on the best way to do something. Super, super powerful. So if you want to get help on Stack Overflow, the first thing you do is try to convey your thought with a representation of that code in the playground. Okay, super important. It'll get you a long ways. There's other things. There's the Go forums. There's the Go Slack, Go for Slack that I think most of you got on tonight. There's the Google Plus community, the Go Nuts mailing list, which is a little nuts, to be quite frank. There's a lot of traffic on there. I don't follow the Go Nuts list very often because I can't keep up with it. I spend a lot of time in the Slack area and the forums area. If all else fails, if you get stuck at some point and you can't figure out what's going on, I'm on Slack under Cory, LaNou, so you can look me up anytime and feel free to instant message me there, direct message me, or hit me on Twitter. I will make sure I try to get back to you and help you in any way I can to solve your Go problem. And a lot of this presentation at the beginning was actually based on Andrew Rand's Raspberry Pi presentation, and that's all I've got. Any questions? Yes?
I was wondering, maybe you mentioned something about this. How fast is Go compared to C?
Really fast, but not faster, maybe, depending. So basically, it's intended to be a C replacement. And I don't know that it's as bare metal fast as C at this point, but typically you'll find that due to processors being as fast as they are nowadays, it's typically fast enough for anything you're going to do. It is a garbage collected language, okay? So you don't want to use it for real-time things. Like you wouldn't want to use it for, medical devices that depend on actual real time, where somebody will die if you are garbage collecting. So those are kind of things that you want to be aware of because it is a garbage collected language. In general, it's incredibly fast. You're seeing it used at scale all over the place at this point. But yeah, it's not C fast, right? And C manages their own memory. But the thing about Go is how many people have been bitten by all of these overflow security errors in the last couple of years. Like the heartbleed, and you name it, right? You just go right on like the bash one, or which one that was. These were all memory allocation overflow errors, right? It's because you have to manage your own memory. And Go doesn't have that security vulnerability, right? So when all these other people are out there, at 3 in the morning trying to patch their servers, I was sleeping restfully because my Go program didn't have that security vulnerability because it's not a memory managed language. It's garbage collected. So it's nice. But yeah, so I don't have exact numbers on that, but I know from experience that most people that are developing with Go, it's not performance that's the issue.
Yeah. How are you supposed to get at like package documentation and interfaces and that sort of thing if you're able to get a package, especially one from GitHub or something?
Good question. All right, let's see, here one. Anybody heard of Raft? Consensus protocol, anybody heard of that? Yeah, it's crazy stuff, trust me, it's what I do with all the time. Pull your hair out. So they have a GitHub repo, HashiCorp does, on Raft. Godoc is super cool. All you do is you put in godoc.org and then the GitHub repo name, and all of your code is self-documented, okay? Now, this is all of their code right there. This is all self-documented. So if they put good comments in their code, it's all self-documented. So Godoc is part of the tool chain that comes with Go. It works locally, and they also have hosts out there. It's fantastic. Most people that write Go libraries, the only thing they read me is the license and the link to the Godoc. That's it. Because they don't have to maintain their documentation at all. As long as they maintain the comments, which you should anyway, right, in your code, it's super easy. And there's some tools like GoLint and stuff like that that will actually tell you like you're missing a comment for an exported method, or it didn't start with the right name because they want you to have like, kind of like these standards on Godoc. So all kinds of tools to help you make sure your documentation is fantastic in Go by default. This is a really nice feature in Go.
This is the same as if you run Godoc package locally?
Anything, yep. Yeah, so if you're running a system library, it's really nice. You look at your Godoc and be like, oh, I see I'm missing some information for people, right? They're going to be upset when they come over because they won't know what this means. It's also another way to say, like, oh, like maybe I should have exported this function because I don't think anybody should be using this, right? It's just kind of like a good gut check. But it makes really nice documentation. Any other questions? Yes?
Can you speak real quick, if you had a bigger project with dependencies, how you would set that up from a files perspective?
Yes, that's always a great question. So Go doesn't enforce any type of file organization, right? And I think a lot of people, when they first come to Go, they're trying to figure out, like, well, where do I put my files, right? Like, should it be this package, should it be that package, what should I name this thing, where should I put it, does it belong here? And it's kind of hard the first time, right? Because there's no enforcement. What I tell people is, try to name your packages based on behavior, right? What does this thing do? And then put inside of that package things that belong to that behavior. And that's kind of the way to think about it. That being said, if you've got a file structure that you're used to, whether it's C or Rails or whatever it is, you've got a convention you want to use it until it feels wrong. Go is really easy to refactor because it's a statically typed language and it's compiled. It's really quick to refactor. There have been people that I've talked to and they said, okay, I'm going to make this change in my program. And I'm going to make a pretty big refactoring. And they would ask me, like, how long do you think this refactor is going to take? And a friend of mine had a project he was working on, he asked this question to the audience, and they said, well, I don't know, a week, maybe 2 weeks, you know, maybe a month. And he said it actually took him 20 minutes to go to refactor. Because it won't build, right? It'll tell you exactly where the line number that it went wrong. So refactoring Go is really, really, really fast. There's also some Go Oracle tools out there already that have like static name analysis. So, you know, if you've ever went ahead and did a search and replace, like via grep or anything like that in a file, and you always overreach because it matches anything anywhere, right? So Go is statically typed, it's static analysis. So if you say Go rename this actual method, it renames only that method based on static analysis. It won't reach anything else, right? That's named the exact same thing in a different package. It's not the same thing. It knows that. So again, refactoring Go is really, really precise. Really quick. So, long story short, use what feels good to you. Try to stick to like naming things based on behavior, and don't worry about getting it wrong. Worry about getting your code shipped, and then you can, you know, kind of feel your way around from there. But yeah, there's no right or wrong answer there. Anybody else?
You should probably mention that files ending with the underscore test are considered test files.
Yes, if you get into testing, if you name anything underscore test, that won't be part of your program. So it's really common if you have a CLI.go and then a CLI underscore test.go, all your tests for the CLI file above it are in that test. So what's actually nice is your file structure just lines up really easy, and good way to show you that real quick. Let's go into the package. services. So you'll see like I have a config go, a config test, a data test. And so you kind of see like these all kind of line up, typically service and a service test. That test file right here is literally just the test for that service file. That's all they do. It won't be imported, but it will run the test for it. Testing in Go is also very, very fast. I think our test meet locally takes like somewhere between 8 and 15 seconds right now for all of the tests in our entire program, like our entire system. And I think that's insanely too long. I'd like to see like a 1 to 2 seconds tops for my entire test week. Now, I think I'm the only person on my team that wants that, but I think it's attainable, and someday we'll get there. But yeah, definitely the minority on that thought. But it's not like other test frameworks where literally like it's time to test the entire project. I guess we'll go to lunch. Go is super fast when it comes to testing. Any other questions? Yes.
Yeah, I kind of heard you mention this earlier, but I missed it. The details, like how do you handle dependency management over time with upgrades and everything?
Yeah, so there's a couple of them. Let me see. The one that we're using at Influx is this. We're using GDG right now, which is basically Go Depths. It's based on Go Depths. It's a little bit lighter version of it. And basically all this does, it creates a manifest. And it explains this. If I go up to this right here. Israeli does a really good job of explaining what it is. It just creates a basic manifest, right? So if you're using any importing, it's basically putting the actual commit right there. That's all it does, right? And then so when you run this, it basically says, okay, based on this manifest, go and get everything that matches that brain locally. So when I compile, I'm running exactly that. So it's a very simple way of doing it. It's not foolproof, but it's pretty close. Anybody else? Awesome. Well, I'm going to be around for a while, and I think some of us are going to go ahead and get drinks over at Darby's when we're done. So I'll be over there too. But again, everybody, thank you so much for coming. I really appreciate your time. Hopefully I didn't bore anybody that's here. So thank you.
So remember bit.ly/GDG survey TC, GDG survey TC, no spaces up there. There will help us. Next month is later. We'll have the final presentations for the Android study jams, and that's all posted on Meetup right now. Thanks for coming up.
GCP next in a couple of weeks.
Yeah, GCP next. We'll be here kind of during the day. It's a work week, midday event. They're good events. So thanks again.
Thanks for having me.
Because people maybe didn't remember that URL, I'll share it to the meetup, just like we did with the other things. So you click fill out the survey for the event, so we can get credit from Google for having had this event.
And you enter yourself to a prize too.
And you may win a prize.
You might win a prize, and then they'll love us more than we can love you guys more.
And we'll hang out for a couple minutes, but we also want to be respectful of our hosts to get home and go to sleep.
Thanks, Cory. I know it's a lot to take in a very short amount of time, but hopefully enough things to create some interest and maybe some capabilities.
It's interesting because I'm in Scala right now.
Okay.
So all those concurrency things is a little different because I usually try not to.
Sure. Yeah, so...
Futures and
if you use the channel idioms in Go, you don't end up doing waits. You end up creating new channels, and it's incredibly fast and efficient.
Okay.
Channels are just they're a little more advanced concept. So if you've never done Go, like getting into channels is hard. When I do the 2-day workshops that I teach, channels are until the very last part of the last day. We have to get so far, like defining everything. They're easy to teach once they've got the basics. But in a 1-hour bootcamp, like it's impossible.
No, absolutely. Anyway, I gotta go.
Thanks so much for coming.